let's talk about code injection, because that's what we're going to basically start doing. So we have an application that's running. We have some value, some quantity in this game, excuse me, in this game that we want to manipulate. So we open up Cheat Engine. We hook it up to the game. We change the value, or we don't change the value. That step's optional, I suppose, but most of the time I like to change it initially just to make sure it's all in memory. You go 2 steps, but we do 3 steps. We can already see they're 22. The red means they've changed, but whatever, I just like to type it. So there you go, it's 2 values. So what are we going to do? We'll fiddle around with the values a little bit to see which one's which. For our purposes, we found the one we want. We don't care about the other one. We all know that we do care about the other one, but for this point, or at this point, we're going to try and boil this down to be as simple as possible. So we found the value. Let's find out what writes to this address so that we can manipulate the assembly instruction. Maybe we want to NOP it. So there you go. There's 1. Let's click it 2 more times. Make sure it goes to 3. It goes to 3. We know we're 99% sure we have the right value. So we could right click on it and say replace with code that does nothing. So what is code injection? Code injection, as I'm going to define it, is instead of replacing this with nothing, it's going to replace this instruction with code that we can arbitrarily write. So more specifically, if we go up here and we go to show dissembler, we have one instruction here at some address 1932EC39, some byte array, and the instruction as sort of interpreted in assembly is this. Let's say we want to replace this one instruction with a whole program. We want to write a program that has all kinds of logic and flags and things like that, and we want to replace this one instruction. This is the instruction where it changes the value that we are interested in, and we want to create all kinds of logic about when to change the value and not to change the value, or not even that. Maybe we just want to write a script because it's fun. Whatever the reason, let's do that. So if we right clicked on this and we said replace with code that does nothing, we would get 6 NOPs as we saw in the previous videos. So how do we go about replacing this one instruction with our own code? It's really quite simple. You make sure you have the right sort of address highlighted. It's not required that you have the right address highlighted, but for the introductory purposes of this video, let's say that you have to have the instruction that you want to inject at highlighted. You go up to tools and you go to auto assemble. You get a blank window. So can we move this over a little bit so we can sort of illustrate it? We can. Alright. So you get a blank window. That's not really helping us. Not doing us any good. I've seen better. So you go up to template and you go to code injection. What is the address on what address do you want to do the jump? It auto fills it in for you. 1932EC39, 1932EC39. That is in fact the address that we want to sort of overwrite with our own code. So you just, I like to double check and make sure they line up, because sometimes I click around and it gets confused. Hit OK. Look at that. We have some assembly code. There's some pseudo assembly up here with Alex and stuff like that, but we have assembly code. We got some, we have an alloc. It's allocating memory. We have some labels. There's some new mem, some comments, original code, some exit, some returns, some address here, which the astute will notice that this matches up with that. So it's kind of telling Cheat Engine this is the address that we're injecting at, or the injection point, if you will. And then what are we doing? Well, we're jumping somewhere to something. Again, new mem, you'll notice some correlation there. Then there's a NOP. and then there's a return here. We'll get into all this stuff, but this is sort of the basic template that Cheat Engine can create for you when you want to do code injection and write your own scripts. So let's bring up Cam Studio and see how much time we have left to really bullshit about this. Alright, so we have a little bit. We're going to go through this line by line. We may not get through it in this one video, but that's how we're going to do it. The first thing is that double slash is comment. You can type whatever you want. Anyone who's familiar with any programming language in existence, from HTML down to assembly, frankly, will know that every language has some facility or some symbol or symbols, whatever, where you can type comments. And the assembler scripts that you'll write in Cheat Engine is assembly, but there are some shortcuts and whatnot, and some convenience features and functions that exist so that you don't have to jump through all the hoops that would be necessary in actual assembly. And the double slash is one of them. This is just, probably lifted straight from C. So, double slash, comment. We're not going to bother with any of that, but anyway, that's what the double slash is. Then you have alloc. What is alloc doing? Alloc allocates memory. So let's repeat that. The alloc function in assembly scripts for Cheat Engine allocates memory. How much memory does it allocate? That's indicated by the second parameter over here, 2048. It allocates memory based on bytes. So if you're at all familiar with memory management and things like that, 1 megabyte is not really 1000, it's actually 1024. So you double that. What are you doing? You're allocating 2 kilobytes. Did I just say that wrong? So let's start over. 1 kilobyte is not 1000, it's actually 1024. So you double that, you're getting 2 kilobytes. But there's some people like to basically round it up to 4096 or 4 kilobytes because the page size, if you will, let's kind of make it a point to maybe look that up, see if Wikipedia page size. There you go. Page size. Traditionally, pages in a system had uniform size, for example, 4096 bytes or 4K. However, processor designs often allow 2 or more, sometimes simultaneous page sizes due to the benefits and penalties. It's not super clear, but let's go up here. A page, memory page, or virtual page is a fixed length, contiguous block of virtual memory. It is the smallest unit of data. 4. Memory allocation. We're going to stop right there. If the page size on your operating system, your architecture, or your computer, whatever you want to say, is larger than 2048, then you're never going to be able to allocate anything smaller than that anyway. So what I like to do is just do that. I mean, that's sort of the standard size, and it's more than enough room so that you can do whatever you want in your script, and it's never going to make any difference because you have 4K, and if you're writing enough code where you need more than 4K memory, then you're obviously going to know what you're doing to the point where you'll know you need to allocate more memory. So what difference does it make? Probably not a whole hell of a lot. But I'm pedantic by nature, so alloc new mem 4096 with a comment to explain why we're doing 4096. Because the page size. New mem. What is the first parameter to the alloc function? The first parameter is basically the label that is going to be applied to the memory that is allocated. So if you're paying attention, you see new mem here, you see new mem here, and then you see new mem down here. So what is going on? Well, alloc comes first because it's going to allocate memory for the code that we write to exist in, or to execute in, or the instructions that we're going to write to exist in is probably a more apt way to say it. And then new mem down here, there's a comment placed by Cheat Engine. This is allocated memory. You have read, write, execute, access. We're not going to bother delineating or differentiating between that. Place your code here. What this essentially means is assembly scripts are driven by labels. So you can jump from label to label, You can return to labels. You can use labels to refer to variables and things like that. If you recall, when we were messing around with Python, we were just being like x equals 5. You can't do that in assembly. That kind of stuff just does not fly. You have to sort of like label x, sorry, nice semicolon there, and then, after you've declared that label, maybe you have to register it, but we'll get to that in a minute. After you've declared or created that label for x, and then you can kind of assign some values to it. And how you do that in assembly is a little weird, but we'll get to that. Or at least default values are a little weird. So again, we're really crossing the Rubicon here. We could have beat our head against what are functions and stuff like that for the next 5 hours, but this is what I like talking about. So I'm moving towards this, and now that we're here, we'll go back and talk about what we have to, but I'm just want to get into this a little bit. So we're going to heavily comment this as we go through it. So here's what we're going to say: memory allocation. So let's talk about that a little bit. Why do we even have to allocate memory? We have to allocate memory because we are going to inject code into this line right here, and there's no memory for us. Do we only want to, as we talked about, we only have really 6 bytes to work with. We're not going to constrain ourselves. That's ridiculous. That's bush league. Instead, what we're going to do is we're going to create our own block of code, and then we're going to jump to it. Essentially, we're just going to, when the processor hits this memory or the instruction at this memory location, it's just going to immediately transfer control over to this script, and then when we're done, it's going to pick up right here. And the benefit that we get by doing this is that we can just allocate some huge chunk of memory, write whatever the hell we want, whatever logic we want, and do whatever we want, and then it will just return control to the actual Shadowrun game at the following instruction. So once you code inject at this point and you create an auto assemble script, you have carte blanche. You have all the freedom you want to do whatever you want. You can, God knows, we're probably going to crash the game 1,000 times working through this. And so we'll start to see all sorts of crazy, we were talking about, oh, well, be aware of this, be aware of that, and yada, yada, yada. All that stuff's going to start coming to fruition, or we will start seeing all that stuff. So why are we allocating memory? Because we need room to put our code. We need room to play. You can't just say, I want to write code and then just stuff it in here. You have to have some memory to put that code in and put your variables in, put your logic in, whatever you want to say. And so that's why alloc is probably the most important and most critical statement in your entire script. Now, there's some sort of, when you write code, if any people watching are familiar with other languages or whatever, you're probably more familiar with like putting parameters and functions or whatever you want to say like that. But sort of with assembly, you just sort of mash it all together. So I'm not going to bother doing any stylistic videos or something like that. But to summarize, we are code injecting at this memory location. We are going to clobber this instruction. And whatever we write in this script is either going to, change how this instruction operates. We could just do nothing in this script, and it would essentially be equivalent of putting a NOP here. And as a matter of fact, that's exactly what we're going to do to test that the framework of our script works properly, is we're just going to do nothing. And when we do nothing, we will see this value not change. But instead of actually knopping it out, we will see that Cheat Engine will jump over to our script, execute our script, and our script will just do nothing. And then it will return control right here, and the game will not crash. And that's how we know that we have a solid framework to work from. And so we'll move more in that direction in the next video.